Good morning, everyone. My name is Jack Levin, and I'm here to present about a few things. Actually, I was traveling here on business, and somebody said there's this great conference going on, and you should stop by and do a talk. So I had literally about 12 hours to prepare this presentation I wrote this morning. So let's talk about things that we do. Basically, currently I work for a company called Nventify in Silicon Valley. But before we get into what we do, I wanted to talk about the things I have done before. So in 1999 in Stanford, I met Sergey and Larry of Google, and I started to work at Google essentially in the very beginning when Google was pretty much a very, very small unknown company. And afterwards, after 6 years or so, I started a company called Imageshack to do image storage for blogs, forums, and other online services. Afterwards, after Imageshack, I started Nventify, which is the company that does image optimization. So I wanted to briefly talk about how it was at Google initially, essentially my first week. So this server setup was my first project. In summer of '99, Larry Page said, hey, we have a lot of servers delivered in the data center. Why don't you go to the data center and connect a bunch of servers together and make sure they work well? So at the time, Google only had about 300 servers. There was no switches and no routers, pretty much no infrastructure of any kind, but things just somehow worked, which was pretty great. So that was my first project, and I was there alone and working in infrastructure team as a single person. A few years later, Google grew to quite a compute farm, and that's what it became. Lots of servers, hundreds of thousands of servers actually. Google eventually came up with a compute cloud that is now competing with AWS or Amazon Compute Cloud. So after working at Google for a while, I have decided to start my own thing. And in 2005, I started Imageshack. So some of you may have heard of Imageshack and used it. It's kind of like an image hosting site known for its yellow frog, poisonous yellow frog. Germany happened to be one of the top countries that used Imageshack for image storage, which is very special. So in Europe, specifically France, Germany, UK, Poland, those were the top countries that used Imageshack. So Imageshack was essentially very similar to a company called Flickr, except Flickr did not allow any sort of image sharing. So image sharing was kind of an option for people who did not want to load images into specific sites. Like, for example, let's say you're building some sort of a website and you need to have image hosting. So what would you do? So there's few options. One option is to run your own server. So you start a server in your own data center, you load your images, and you become essentially a website designer as well as an IT engineer that actually requires to run all of your infrastructure yourself. Alternatively, you can go to AWS or Google Cloud and use their API to load your images. Or you could use Imageshack, and Imageshack has a very simple UI, very simple interface. You load all of your images from your computer image library into Imageshack, and they become available for sharing anywhere. So for example, you could use Magento to start your web store, or you can use Shopify, and you can load images into Imageshack and use those images across all platforms. So whether it's Magento, Shopify, eCommerce, or wherever. The key takeaway here is that rather than loading your images into some single system, you can take those images, put it onto Imageshack, which is kind of like Switzerland, right? That's what we used to say to when we asked what Imageshack is all about. So we're kind of like this neutral territory where you can load your data and then share your data anywhere. So you can run multiple stores or multiple web stores using single source image. And you can also use Imageshack for other things, like, for example, sharing images on Reddit or on forums or other blog posts or what have you. So Imageshack was a very interesting project, and at the top of its popularity, we had close to 60 million unique users coming every month, which is a lot of traffic. That being the case, scaling became a really, really big issue. We had about maybe 2 to 3 million of images uploaded daily. Now, as you can imagine, images were coming in different sizes, different resolutions, and our goal was to scale those images properly so that they can show up in a nice formatted grid that you can use, that you can click on and navigate between landing pages. So that became kind of like a scaling issue, and we worked for a few years trying to optimize images so that when people load images in, we can generate different image sizes as images come in. And that solution was very inefficient, very slow. It required a lot of servers, a lot of compute power, and a lot of management. Then in 2014, so fast forward a few years, Pinterest, which is a very popular site that you probably know, came to prominence. So what Pinterest does, in a nutshell, they allow you to create what they call image boards. And those images that are coming in as essentially links from websites and resources anywhere on the web. So you can, for example, if you find an interesting image, you grab its URL, give it to Pinterest, and Pinterest kind of sucks it in and creates a board for you. Pinterest problem was very similar to Imageshack. They needed to represent images in different formats. For example, creating different galleries so that you can show those boards to your followers, and your followers can consume those images and load those images quickly in different formats. So I happen to have had a friend who worked in Pinterest, and he essentially sent me an email and said, "Hey, Jack, I know you're doing this for Imageack. Can you do this for Pinterest also?" And myself and a group of engineers at Imageack, we decided, hey, why not? We could make it a project that could actually work as a B2B solution where other people could use it. In other words, scaling images on the fly would work really well for Pinterest because they had even more images than Imageshack. So Imageshack maybe had 1 billion images or so stored in an image library, but Pinterest had dozens of billions of images, and they had even more image versions. So different size images were everywhere. So again, what I wanted to talk about is the scalability. So this is a quadcopter. It's kind of fat and big, and you can fly in it. So it seems to be like a simple problem. You just make things bigger. In reality, it's not so simple. So moving forward, I really wanted to talk about e-commerce and what we do for e-commerce today. As you know, e-commerce websites sell products, whatever the products are. Those products are usually visualized by images. So whether it's shoes or jeans or backpacks, whatever, those images must load quickly on any e-commerce site. If those images do not load, that means you will be losing your sales to your competition. E-commerce happens to be highly competitive space. Like for example, in US we have one of the 2 largest sites or companies called Macy's and Nordstrom. They sell pretty much this very similar products. You can buy Nike shoes here or there. Your choice as a consumer could be Nordstrom or could be Macy's. Now, if Nordstrom does not load the shoes that you like, you click on the product and nothing loads, you have an option to go to Macy's. And after a while, if you have a poor experience at Nordstrom, you're just going to stop going to that site at all. So they're going to lose you as a consumer, and Macy's going to win. So performance and optimization of products that are shown on the website is highly important for e-commerce websites. Now, this is a very interesting infographic, and this is something that I learned years ago, but a lot of people don't know this. If you lose 1 second or 1 second delay on the web page, actually will cost you a lot of money. 1 second delay will cause you about 7% in loss of conversions. Now, conversion is something like, for example, you go to an e-commerce site and you choose your product, and you want to click on Add to Cart. Add to Cart, and then a purchase is conversion. Your website will lose 7% in conversions if you have 1 second delay. Now, your web page already loads maybe 3 or 4 or 5 seconds per session. If you do not save on seconds, you actually end up losing money and your revenue drops, and somebody else will sell that product instead of you. So what are the solutions to loading pages quicker? Specifically, in light of mobile devices coming online every day, there's more and more mobile consumers. Mobile screens are changing all the time, so you need to be very, very quickly adapting to different screen sizes so that you load your images and your products and your web pages properly. So one of the solutions is, you probably have guessed it, responsive design. So responsive design, basically what it means is that you have different screen sizes and your website will adapt to, with its layout, to the screen size. Unfortunately, and I have learned this recently, 70% of desktop assets are served to mobile devices. What does it mean? That means that anytime you're building a blog or building an e-commerce site, it is very likely that 2/3 of all of your images are really meant for desktop, but they're being loaded into mobile devices. Now, what the mobile device does when it happens, it loads this image. This image is too large for its screen. It actually will throw away 2/3 of its information. So you just transmitted useless data. It will be thrown away by the phone anyway, and you have lost precious time when it comes to performance. So I really like this sort of infographic, and I like it because it was originally spoken by Bruce Lee, and Bruce Lee is kind of like my hero. Content is like water. So if you put water in a cup, it becomes the cup. If you put water in a bottle, it becomes the bottle. It's kind of, I mean, you see cups and bottles and teacups right there, but then over there you see the mobile device and a desktop. So essentially, your content must form inside your screen, and it kind of makes sense. So product images, obviously, again, are very important. This is essentially where this is kind of like what Bruce Lee thought about. This is what we think about today. We think about websites and essentially e-commerce pages loading well so that you can actually see the product that you want to buy. In many cases, if you do not adapt your desktop assets to become responsive on mobile, you will end up loading a very big header, essentially explaining what you're about to buy, but the product itself is going to end up below the fold of the phone somewhere right here. So what are the approaches to scaling images and why images needs to be scaled? So responsive images go hand in hand with responsive design. Responsive design is specific to the web page scaling and layouts, but images can still be loaded the wrong way. Like, for example, your layout changes, but then your assets are loaded with very fat and slow loading images. So how do we solve this problem? And there's few different approaches to image scaling and optimization. Let's say that you have about only 1,000 products that you're selling online. Now, 1,000 products that have, let's say, at least 5 presentations. So in other words, let's say it's a shoe or a backpack or whatever, and the pictures are taken from each side. Now, so 1,000 becomes 5,000 files, and now you want to show those files in the responsive manner through the responsive design, where you have an image version for each device type. Specifically, loading for mobile is different than loading for desktop. For desktop, your resolution could be as large as 2,000 pixels for your screen's width. Now, for mobile, it could be something like 500 or 600, or even less, like 300. And of course, when we talk about thumbnails, those thumbnails need to be done even smaller. So there's two general approaches. One is for small media library static images. You just make image versions. You just basically say, here's my image library with 5,000 images. I'm going to make 10 different versions of each image. So you go from 5,000 to 50,000 files. It sounds like a lot, but it's really, in terms of computing storage and file storage, it's really not a lot. 50,000 files you can easily store on Amazon AWS S3, and it will cost you perhaps $10, $15 a month to store all those files. Now, if your image library and if your products do not change a lot. That's a fine solution. You don't need to do anything. It's very simple. You don't need to manage anything. You just need to make your files smaller, shrink them up, store them in different folders, and then serve them with your responsive design on your mobile version of your site. Very simple stuff. Now imagine you're a company that's rapidly growing. Like for example, About You, right? So About You is a very popular company here in Germany. A lot of people doing transactions online. So About You has a lot of what they call articles, and articles are the items that they sell. Each item maybe has about 10 presentations, and each presentation must be visualized in multitude of different ways to fit the mobile screens, as well as any browser of any size. Now the solution there is no longer, so static images is no longer becomes a good solution, simply because when you refresh your image library, your media library, you may end up taking in 1 million files every quarter. Now, making 15, 20 different versions of 1 million files becomes somewhat of a difficult task, because now you're producing dozens of millions of files. Not only that you need to store them, but it is the production process that is very cumbersome and hard to do, and it requires a lot of babysitting, a lot of engineering, and it's no longer as simple as when you only had 1,000 products. So in large enterprise e-commerce companies, this really becomes a big issue. So the solution is dynamic images. Now, what does it mean? So dynamic images is a situation where when your user comes into the website and your website identifies that user as a mobile user, the image is then converted automatically on the fly into proper formats. Now this solution has some benefits and it has some cons as well. And here I'm actually outlining pros and cons. So with, again, with the static image library approach, it's very simple to start when you start your kind of like e-commerce company or e-commerce presence online. The development effort is very low, and there's many open source tools that you can use, like for example ImageMagick, or you can use Python or Ruby or anything. It's all available. Just type image scaling or image resizing in Google, and you can immediately find tools to change things. Now, dynamic image library pros are very simple. When the user comes, images just automatically become of proper size. Now the problems are somewhat more complex, because first of all is that you need to build that system first, and there is no open source or any kind of sort of solution that's available. There's some Ruby plugin that plugs in ImageMagick into Ruby, and there's the Python Tumblr project, but none of those projects actually scale. So in other words, you will end up running maybe 100 servers if your traffic is significant enough. And running 100 servers, running any sort of software is difficult, no matter how simple the software is. Just keeping a cluster running is not a clear task. You actually need an engineering team. You need a logging team that actually looks at logs and has on-call schedule and does things like monitoring and fixes things when things are broken. Now, when you run 100 servers in a cluster, there's 100 things that can go wrong. Like for example, 10 of your servers may become slow, and you wouldn't know that they're slow. So those 10% of those servers running in a cluster of 100 actually slowing everything down, and you don't even know which ones. So the difficulty there is that you actually need to think like an operations engineer, but all you wanted to do is compress and resize images. So again, this becomes somewhat of an issue. The dynamic image manipulation often does not scale. So whenever there is an impactful influx of traffic, like for example what we call in the States Cyber Monday, where every online store in the US actually drops prices by 30% or so. Everybody goes online and tries to buy things. So their traffic almost doubles or triples or quadruples for some of the sites. The problem there is that if you're running dynamic image resizing, it is difficult to scale to the influx of traffic, because you cannot just say, hey, I have 100 servers running on the farm, but now my traffic has tripled. I need to add 200 more servers to my cluster. It's actually somewhat difficult to do. Now, there's ways to do it. You can do it with AWS autoscaling, but again, auto-scaling, even though it works, it's not an immediate solution. You do require some engineering effort to get it online. So my team and I, we kind of looked at the dynamic image manipulation. We decided that this is the right thing for most of the people to do. The problem is the investment of time you need to spend to get that solution off the ground is significant. And all you really want to do is sell products online. Present great UI, great UX, great user experience. You really do not want to be spending $1 million or thousands of dollars in engineering, thousands of engineering hours to build something that is not core to your business. Now, what's core to your business is making sales and making users happy so that they can buy your products quickly. So what we decided to do is we decided to come up with a cloud platform that you can turn on your e-commerce sites, e-commerce website in 5 minutes or less. And we called it ImageAzor Engine. Now, what ImageAzor Engine does, it actually works in different forms. First of all, you can go to ImageAzor.com, you can make an account right there, and you can point ImageAzor.com to your image storage. So your image storage could be Google Cloud, or it could be S3 on AWS. You point ImageAzor there, and then you have an API endpoint that allows you to manipulate images in real time. Now, ImageAzor Engine is written in C, and it's written essentially using very low-level libraries. So in other words, it's not PHP, it's not Python, it's not Ruby. It is extremely fast. It can manipulate images in real time under 50 milliseconds or faster per image conversion. Now, the way that we approach dynamic image optimization, we actually not only give you the tools to change images on the fly by changing your URL parameters, we actually also run an analytics engine on top of ImageAzor. Now, what this analytics engine does is that it identifies the type of a user that you are. Like, for example, you could be a user using desktop at home. Now, this is like profile number 1. You could be a user walking about in town using your Android phone. That's profile 2. Profile 3 would be the same user, but your phone is not an iPhone, but Android. Or you could be the same user now traveling on the train between Hamburg and Bremen, and the connection varies between being really good like an LTE or 4G, 3G, and eventually Edge. Now, what our system does, it actually measures your network performance as well the type of the device that you're using, and then it serves images on the fly very quickly that are appropriate for your device and the connection type. Now, you may be asking, what is the difference between devices? Actually, the difference is very important. So currently, iPhone can load JPEGs. However, Android can load an image format called WebP. Now, WebP format is very similar to PNG, but it has superior compression to PNG, and it has much better loading time overall, just because the file is lighter. So we can detect that they're using an Android phone, or if you're using a Chrome browser, by looking at your user agent and automatically change those images to the proper formats so that they load much quicker for your client or for you as a consumer. So now, ImageAzor is used by a few companies in the US like Snapfish and Nordstrom and Imageshack. There's also Vango and Uyala and Tantan. Tantan happens to be in Malaysia, and it is kind of like a Netflix clone, but happens to be in Malaysia. The ease of deployment is something that we really wanted to focus on. So the only thing that you really need to do is change your image source URL and point it to ImageAzor. Now, this is something that you can run and do yourself. It's not really very difficult to learn how to do this, and I'm going to show some examples real quick. Now, this is Nordstrom. So Nordstrom right now, Nordstrom.com, uses ImageAzor on Amazon AWS. They have about 50 million products that they're selling from their site. And each product has about 20 different variations of each image. So scaling and fast image transformation was very important for Nordstrom, and they're one of our clients. The other client is Snapfish. So Snapfish is very similar to a company here in Germany called CV, essentially photo books for the printing company, where you can say, here's an image of a bag, but here's my image that I took of a tree and a car, and I want to superimpose those images and show that image on an image gallery or an image landing page. Now, ImageAzor again is very simple to start. There's few variations that you can do. You can use a very simple model, essentially pay as you go per API query. So if you're a startup or you're building something or you have some sort of a project, it's literally you literally get charged for your queries. So 1,000 queries, you pay $1. And if you do not use ImageAzor today or tomorrow, you're not charged because you're not using anything. But anytime you use anything, then your dollars and cents kind of accumulate. If you're a larger company, you can go to AWS Marketplace and launch ImageAzor as a virtual machine directly from AWS. So if you have an S3 storage full of images, you have millions of images, you can launch an EC2, that's what AWS calls their virtual machine, and you can connect it to your S3 bucket, and it becomes your infrastructure. Your images don't go anywhere. They literally live in your own virtual cloud. That is your personal cloud, and you can transform images right there at the source, which is very important. So this is the team right now. There's 4 business people and 3 engineers, and we have some consultants that are working on this project. And I have a few minutes left, so I really wanted to jump quickly into demos. So let's see if this works. One sec. And for that, I need the browser. All right, so first of all, what I'm going to do, I'm going to go to Google, and I'm going to show you how easy it is to manipulate images using ImageAzor. So google.com. How about I'm just going to type dogs. Now, I haven't done this query this morning, so this is completely organic demo. So what I'm going to do, I'm going to choose a picture that is large enough that we can dynamically manipulate. Well, how about this one? So here's an image of a dog right here. So I'm going to grab this URL. So the next thing, what I'm going to do, I'm going to type imageazor.com. And that's, by the way, how you can start using ImageAzor. You just click register, then log in, and you can get to use all the features here. What I'm going to do, I'm going to go to Sandbox. And Sandbox has all of the API features available. I'm going to paste this URL right here. Now, what happens behind the scenes is that ImageAzor takes in the data, and you can actually see if you can make this image load faster or make it smaller. So like, for example, format, you can say, I really want to see how this image looks in WebP. So in WebP, the original image was 75 KB. Now it's 26 KB, which is very, 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 very good compression. Now, notice that the image resolution have not changed at all. It stays the same, but all you have to do is essentially just turn on WebP right here. Or you can go to Auto, and Auto basically is a format parameter here that will basically say, ImageAzor, please detect the browser type I am on, and then serve the appropriate image format for me as a client or for your clients. Now let's go and do some image transformations. So what I want to do, I really want to make this image smaller. So let's go to about 500 pixels right there. Now this dog looks adorable as in a rectangular picture, but what I really want to do, I want to make it into a square. So now it became a square. So if you're building an app, or if you're building a store or a gallery and you need square images, you can build images that look square, and you can remove content around it. So you can literally format your viewport. And again, the original image is 75 KB, but the image here, because you have a lot less pixels, is only 13 KB. Now, I want to make sure that you guys can see that this is not some sort of JavaScript magic. So what I'm going to do, I'm going to delete these parameters right here. So this is the original picture, and changing the width of an image is as simple as this. So W equals 400, boom, image is resized. Now let's come up with some alternative resolution like 333. So you can see that image is rapidly changing its format. So it is real-time transformation. There's almost no delays of any kind. Of course, it makes sense to put the CDN on top of your image library so that you can once images are converted, they're cached in the CDN so that they're pushed around the world and content becomes available closer to where the users are. Now, in case of Nordstrom, let's look at this real quick. So they have some advanced stuff happening with their website. So let's look for things like Nike. All right. So one of the biggest problems that Nordstrom have had is that their studios were producing shoes that had too much white space. Now, when I say too much white space, I don't know if you see this. You see how this rectangle right there has a lot of white. Now, this image is fine for the desktop, but once you load it in your mobile browser, because of the white space, it takes pretty much all of your screen, and then the bottom and the middle of the shoe actually disappears behind the screen. You only see the top right here. So that was one of their problems. So when they approached it, they said, hey, can you solve this problem for us using computer vision? Now we asked them, well, why don't you just ask the studio to take pictures of your products properly? And they said, well, they actually take millions and millions of pictures. We can't ask them to take even more millions of pictures of the products. It doesn't make any sense. So I said, fine, certainly we can look at this and see if we can manipulate images using computer vision. So this image right here, you can actually see that it's being manipulated to be seen better. And if you look right here, ImageAzor parameters are indicated on the top, and of course you can change the resolution. So I can say I really want to see a smaller image. Okay, let's change this to 400 by 400. So you can see it becomes nice, nice and square, and there's no extra white space at all. Original image looks like this. So without the parameters that ImageAzor applies, you can see that this image actually has a lot of white space on top, which is fine for desktop, but not fine for mobile. So for mobile, they really wanted something like this. And you can easily do that with ImageAzor. So that's pretty much it in a nutshell. I have about 10 or 15 minutes more. If anybody have any questions, I can do more demos, go over the API, give you more examples, so on and so forth. By the way, the API page is right here. You can pretty much go to docs.imageazor.com, look at the API, and see what you can do. So you can do things like face detection. You can remove content from images that is not interesting. Like, for example, this frog is really sitting on the left side of the tree. Right side of the tree is not interesting. It just have wood in there. So you can apply this parameter right here, and your camera will move to where the frog is. And there are many other things that you can do right here. Like, for example, you can say this image has been taken, even though it's kind of like a fake image, but let's imagine it's been taken during the evening time and there was a lot of yellow. You can say auto level equals true, and then there will be blue tones added to it. Now, again, this is useful for mobile apps. It's useful for mobile websites in general. There are other things you can do. You can make images with brighter colors by adjusting sharpening. And again, the examples are right here. So you can essentially pass the URLs and make images more interesting. You can also do Instagram-like filters, where you can say, I really want my image to be black and white. So if I were to go right here and load this like so, and I'm going to say format equals 21. I know 21 maybe it's not 21. Yeah, it's not changing color, but generally it's supposed to turn black and white. And the way that you can see this is there are options in the actual sandbox. So there's a few other things that you can do that are very interesting. You can do things like object recognition. Like, for example, here's a camel and here's a car. So if I click on labels, you can see animal, camel, mammal, buggy, carriage, vehicle, automobile, and the car. So by passing on recognition equals labels, you can extract image content and sort your image content based on the kind of content that you can see. So this is a pretty cool demo that I actually forgot to do. So let's look at this real quick. So let's go back to Google. How about we look for something natural like river. Go to images. And so here's some image right here. So I'm loading it up. And that website is very slow. It's not loading anything. How about this one? All right, there we go. So what I want to do is I want to paste it right here, and I'm going to get rid of all the parameters. So paste. And I think my internet is gone. Let's try this again. Okay, there we go. So if I click on labels, we can actually see that this is a creek, outdoors, water, rocks. Obviously, it's not the sea, but the system thinks that there is a 60% chance that being the sea, but 90% it's a river, which makes sense because this clearly is. And you can see, yes, you can basically say we might be guessing that this is a river because there is a river on the file name, and I say fine, but what about the rock? Right? I mean, the system does recognize that there are rocks in there, and those are the rocks right here. So, any questions? Yes? Orders of parameters does not play a role at all. You can set the parameters as you wish to be whatever they are. Questions, anybody, about fast loading images that you can load very quickly into your mobile devices by using ImageAzor? I'm sorry, what kind of images? Retina images? Yes. So let's say that you want very quickly to change image scaling. So there's an option called DPR. So whenever you detect your clients by using user agent, like for example, you know that people are coming from MacBook Pro, you can say, let's not change the actual resolution. Let's not compute the resolution. Let's just change the DPR to be 2. Now 2 in DPR basically means multiply my width and height by 2. And you can set it to 3 as well. So whatever your original thumbnail is set, like let's say it's like something really small, just below 300, your DPR will multiply those numbers by 2 essentially. So, and you can use it right here. So if I go to 3, you can see I just doubled the resolution. I can also go to 4, and it becomes even larger. So essentially it acts as a multiplier, and you can use that to multiply your pixels. Yes?
And that's nice that you can manipulate like you did with your app.
Yeah.
But what I don't want my users to be able to manipulate that.
Okay. If you do not want your users to manipulate, there's 2 options that you can use. Option number 1 is that you can set up a proxy server that manages your policy as far as which ranges are available. You can literally say, here's my 3 resolutions I want, everything else do not accept, and send a 403 error or a 502, whatever you choose. That's one option. The second option, you can say, I really do not want to do anything or think of anything. I just want images to load properly from their viewports or image views from HTML. We have a system that can scan your web page, recognize how large your images should be, and then build a map that will automatically adjust image sizes based on the HTML codes itself. So you don't even need to use the parameters at all. Our system can scan your web pages and present images on as needed basis for you, essentially. So no security is required because everything, the policy is driven by your web page image size. Yes.
Can I upload gigantic scientific satellite images and it's still 1,000 API requests, or is there a difference between little thumbnails that get uploaded and really huge gigantic files? The accounting is basically the same in your...
When it comes to billing is the same. However, your performance may vary. Obviously, there's no magic in the world. The larger the file is, the slower it will be transmitted from your source to ImageAzor. I mean, you cannot exceed the speed of light, right?
Yeah,
so there you go. So you will pay with performance.
Yeah, but for scientific applications, it is a one-off job to...
Yeah, that would not be an issue. And if you're doing stuff that's scientific, you can actually go to AWS Marketplace, and from the marketplace you can basically try running ImageAzor. You can say like search for ImageAzor right here, and you can launch servers of any size. Like you can say I really want this gigantic server with 64 cores and it has unlimited bandwidth, but you only will run it for an hour, so you will pay $3. Right, which is great because your task will be done within an hour, and then you shut it down, and you go back to whatever you originally were planning to do. So that's another way to run ImageAzor in pay-as-you-go model, where you're only charged for the number of hours that you use the system for. And you can find ImageAzor on Amazon Marketplace by essentially typing Nventify or ImageAzor, and you can launch your own virtual machine in your own cloud. Unfortunately, object recognition is only available under ImageAzor.com, so only here. So, and that's because we're using neural networks that are actually running in our own data centers. So it wouldn't be available for you running locally in your cloud. Any more questions about fast images? Okay, well, let me ask you a question then. How many of you are carrying iPhones? Okay. And what about Android? I would say there's more people with iPhones. Well, the good news about iPhones is that Apple just came up with a new image format called HEIC or HEIF. We're working hard to actually make that format available. So just like WebP for Chrome, HEIF will be available for ImageAzor so that images can become even more optimal for Apple devices. And Safari will support it as well, I'm sure. All right, last question, anybody? Okay, thank you.